Lesson 10.2, Simplifying Radical Expressions. A few definitions that we need to look at today. A radical expression is an expression that contains a radical. And we will be simplifying radical expressions so that you need to know that in order to consider a radical expression in simplest form or completely simplified, here are the conditions that must exist. A radical expression is simplified when, number one, no radicand has perfect square factors other than 1. Number two, no radicand contains fractions. And number three, no radicals appear in the denominator of a fraction. Okay, and just as a reminder, the radicand is that which lies underneath the radical symbol. Okay, so under the radical symbol, no radicand can have perfect square factors other than 1. No radicand can contain a fraction, and no radical can appear in the denominator of a fraction. Okay, a couple of properties that you need to learn today. There is a product property of square roots, and here's what it says. It says that the square root of a times b is equal to the square root of a times the square root of b. Okay, so there's also the quotient property of square roots that tells us the following. The square root of a over b is equal to the square root of a divided by the square root of b. We will be using these properties when we simplify radical expressions. Okay, let's start by simplifying number one. Number one, radical 80. The first thing you need to do is you need to go ahead and factor 80 into its prime factorization. So here we go. If you need to make a factor tree, you can do that off to the side. So two numbers that multiply together to get 80. I guess you can say 4 times 20 is 80. 4 can be broken down to 2 times 2. 20 can be broken down 4 times 5. And then 4 can further be broken down as 2 times 2. So I'll bring this 2 down, and this 5 down. And there's my prime factorization. So let me write it down. I have 2 times 2 times 2 times 2 times 5. Okay? Now, I can rewrite this way. As I match pairs of identical factors, what I'm doing is I am pulling out squares that are factors of my radicands. So I can say, well, that's the square root of 4. And then I can say that that can also be considered the square root of 4. And then we have the square root of 5 left over. Okay, because 2 times 2 is 4, so the radical 2 times 2 is radical 4. Now there's more simplifying that we can do here. Radical 4 is 2 times radical 4 is 2 times radical 5 is not simplifiable. It's radical 5, so 2 times 2 is 4 radical 5, and that would be radical 80 in simplest form. Okay, all right, let's go on to number 2, radical 54. Okay, so radical 54. 54, the prime factors, I would say let's do 6 times 9. So this is 2 times 3 and 3 times 3. So I have 2 times 3 times 3 times 3. So let's write that down. 2 times 3 times 3 times 3. And I can identify that in my radicand I have a perfect square factor. 3 times 3 is 9. That's a perfect square. So I can rewrite this expression this way. Radical 2 stays in the radical symbol. Radical 9 and then radical 3. Okay. So then I can further simplify by writing radical 9 as 3. And then I can combine radical 2 and radical 3, and that would be radical 6. Multiply those. So there is my simplest form. Okay, radical 180. Okay, let's try this one. 180. Let's break that down. I'll do 18 times 10. I'll do 2 times 9. That means 9 is 3 times 3. And this is 2 times 5. So we want to write those in order under our radical symbol. So it's 2 times 2 times 3 times 3 times 5. Okay? So radical 2 times 2 is radical 4. Radical 3 times 3 is radical 9. And then radical 5 cannot be simplified. Radical 4 is 2 times radical 9, which is 3, times radical 5. 2 times 3 is 6, radical 5, and that is my simplified radical. Okay. Number 4, try it on your own. Come back and check your answer. Okay, there's your solution. 2 radical 13 would be simplified form. Okay, let's go on. Here we go. 2 radical 2 times radical 14. Okay, that can be rewritten as radical 28. Okay, and we know that we can factor 28. 28 would be 4 times 7, and 4 we know is a perfect square. So actually I would write it this way. I would say radical 4 times radical 7. Radical 4 I know is 2, radical 7. Okay, in retrospect, if I were to do this over again, what I would do is I would say, let me just factor them both and combine their prime factors in one radical symbol. So it would be 2, radical 2, I'm just bringing this one down, and then 14 is 2 times 7, and then I would recognize my perfect square there, so I know this is radical 4 times radical 7, and again it's 2 radical 7. So that's how I want you to do these. Alright, so let's do this one in that manner. Here we go. Radical 5 can come on over as radical 5, and then 10 can be written as 5 times 2. Well, there is my perfect square, so let's go ahead and simplify that. Radical 25 times radical 2, and radical 25 we know is 5 radical 2. Number 7 on your own. Okay, and for number 7, the answer is 4 radical 3. Okay, moving right along. Let's look at number 8. one of the criteria of a simplified radical expression is that there is no radical symbol in the denominator. All right? Radical 35 over 15 can be rewritten radical 35 over radical 15. There can't be a fraction within the radical symbol, but there can also not be a radical in the denominator. So, in order to take that radical symbol out of the denominator, we need to take radical 15 and square it. That's the opposite of the radical, so that's going to undo that radical symbol. And we need to multiply our radical expression by a form of 1 that will remove the radical symbol from my denominator. Okay? So here I know that radical 15 times radical 15 is 15. And then I can rewrite these factors under the radical symbol up here so that I can simplify. So radical 35, the factors are 7 times 5. And for 15, my factors are 5 times 3. And I wrote them in that order purposefully so that you can recognize the perfect square in there. Okay, so let's rewrite this as radical 25 times radical 21 over 15. So radical 25 is 5, radical 21 over 15. And then, yes, we can simplify because we have a factor of 5 in common in the numerator and in the denominator, so we can reduce. Now you cannot reduce what's in the radicand, okay? So that stays in the radical symbol. So our solution is radical 21 over 3. Okay, let's try number 9. Remember, you are not allowed to have a fraction under the radical symbol. So we need to rewrite it this way. But you are neither allowed to have a radical in a denominator, so we need to get rid of it. The way we will get rid of it is we will multiply this radical expression by a form of 1, radical 10 over radical 10, and that will take that radical symbol out of my denominator right there. Radical 10 squared is 10. Now what I need to do is I need to simplify my numerator. So let's do that. So 45 would be radical 3 times 3, that's 9 times 5. Okay? 9 times 5 is 45. And then radical 10 is 5 times 2. And I did it this way on purpose so that I could match up my perfect squares. Here we have radical 9. And here we have radical 25. So let's rewrite this. This would be radical 9 times radical 25 times radical 2, all of that over 10. Now we can simplify. Radical 9 would be 3. Radical 25 would be 5. 3 times 5 is 15. Radical 2 over 10. And now we can simplify because we have a common factor of 5. This is a 3, and that would become a 2. And so my simplified radical expression would be 3 radical 2 over 2. Recall that you cannot simplify what's under the radical symbol because that is the square root of that number, not that number per se. Okay. All right, number 10. Try this one on your own. Come back and check your answer. Okay, when you simplify this radical expression, you're left with radical 2y divided by 2 over 2. Okay, here we go. Number 11. 3 over 5 plus radical 2. Notice that here, the radical is in the denominator, but it's part of an expression. So, in order to get rid of that, here's what you need to do. You need to find its conjugate. You might remember that word, one of our vocabulary terms from chapter 8, I believe, where we were factoring differences of squares, and we would find the conjugates. And a conjugate of, for example, a plus b would be a minus b. So, the conjugate of 5 plus radical 2 would be 5 minus radical 2, and we would have to multiply this expression by a form of 1. 5 minus radical 2 over 5 minus radical 2. This does not change its value, it simply changes its form. Multiplying anything by 1 doesn't change its value. Okay, so let's recall what happens when you multiply two conjugates. You get a difference of squares. The difference of squares would be, let's take the first term 5 and square it, that's 25. It's a difference, so it's always going to be minus. And let's take the second term and square it, so radical 2 squared is 2. Okay, now in my numerator what I need to do is, I need to basically distribute as I multiply these together. Okay, so let's do that. 3 times 5 is 15. And then 3 times negative radical 2 is negative 3 radical 2. Now let's simplify. 15 minus 3 radical 2 over 23. And that would be our simplified radical expression. Okay? Number 12. Here's a similar problem. So, we need to get rid of the radical symbol that's in our denominator. So what we will do is we will find the conjugate of that expression, and we will multiply top and bottom by the conjugate, by a form of 1. So recall, the conjugate of 2 plus radical 2 would be 2 minus radical 2, and that's what we're going to multiply to the numerator as well as to the denominator. Remember that when you multiply conjugates, you wind up with a difference of squares. So square the first term, that's 4, and we'll subtract the square of the second term, that's 2. And now we're going to distribute as we multiply here. So 3 times 2 is 6, and 3 times negative radical 2 is negative 3 radical 2, and we'll simplify. 6 minus 3 radical 2 over 2. And that would be our answer. Okay, try 13 on your own. Pause the video, come on back, and check your answer. 21 plus 7 radical 7 over 2 would be your answer. Okay, let's do some practice. Here, all you are asked to do is simplify each expression. So we need to simplify those. And here we're also going to simplify 4, 9, 13 and 14. Okay? We will discuss this tomorrow. Once again, I'll take all your questions. Make sure you write them down and remember what they are. Simplifying radical expressions, just so you know, takes a lot of practice. After a while, you get real good at noticing what those perfect square factors are, and you are pretty much doing a lot of mental math. So stick with me. It is a process. It takes a lot of practice, and it is required that you practice this quite a bit to get good at it. So we will do a lot of that tomorrow. Okay, God bless you. Have a great night.